conic sections. Press the Run button to start the narrative. Read the footnotes for details. Conic sections are geometric figures formed by cutting a circular cone by a plane at different angles. They share an analytic expression in polar coordinates given in the display, where E is a parameter characterizing the different sections, called the section's eccentricity. The different figures are reached through the conic section input control. The display presents the circle as a conic section. The circle follows the common conic sections formula, with an eccentricity E equals 0. It is a closed figure with a single focus F at the circle's center. With the eccentricity E equals 0, the formula gives the radial distance r from the focus F to a point P on the circle a constant, independent of the angle theta. The radial line to a point P on the circle is at right angle to the tangent line T to the circle at P. The ellipse is a conic section of an eccentricity E greater than 0 and less than 1. It is a closed figure with two foci, F1 and F2, and follows the common conic sections formula. The radial length r in the formula is measured from one of the foci to a point P on the ellipse. A property of the ellipse, the sum of radial lengths from F1 and F2 to a point P on the ellipse is constant, independent of the angle theta. A further property, the angles marked by the red dots made by the radial lines from F1 and F2 with the normal line to the ellipse are equal. The parabola is a conic section of eccentricity E equals 1. It is an open figure with one focal point and follows the common conic sections formula. The vertical line L and the focus F in the display are at equal distances and on opposite sides relative to the parabola vertex. A property of the parabola, the radial distance from F to a point P on the parabola equals the distance from P to the line L. The dashed line represents an incident light ray parallel to the parabola's axis. The angles marked by the red dots made by the ray and the radial line from F with the normal line to the parabola are equal. The hyperbola is a conic section. It is an open figure with two branches and two foci, F1 and F2. The figure follows the common conic section formula with an eccentricity E greater than 1. The radial distance r is measured from one of the foci to a point P on the hyperbola. Shifts of the radial line from one branch to the other branch of the hyperbola occur at two angles theta, at which the denominator of the conic section formula becomes 0. Visit the website www.cyberphysics.academy for a full view of the tutorial. Send comments to contact@cyberphysics.academy.